Hello, I'd like to go over some of the features we've recently added to the CX380C. In the cable modem mode, we added some updates to the upstream's detail screen. We've added frequency response trace and peak to valley for an OFDMA channel. This frequency response trace is basically the spectrum response of the OFDMA's bandwidth, kind of like a sweep response for the OFDMA channel. We've also added frequency response location view. This provides both the cable modem and the CMTS view of that frequency response trace, giving you the ability to see what the cable modem is transmitting and what the CMTS is receiving. This presentation will cover how the response in the CX380C is generated and why. With this feature, the technician can visually see how the HFC plant affects the upstream channel's response between the cable modem and the CMTS. The technician now can examine the upstream's channel's performance and address any impairments. So let's first talk about DOCSIS pre-equalization. In the CMTS has the capability to control the equalizer settings in cable modems. This was introduced back in DOCSIS 1.1. So with pre-equalization, what it does is it modifies the cable modems upstream to transmit differently when impairments are present. So when an upstream impairment is present, the CMTS will communicate back to the cable modem to compensate for this impairment. And then once that is done, the upstream carrier that is received at the CMTS will be equalized and easy for it to demodulate and work on it. So I've done a couple experiments in my lab, and I got some examples I'd like to go over with you that kind of explain the difference between pre-equalization enabled in a system and pre-equalization disabled in a system and how it affects the cable modem's performance. So in this first example, I have pre-equalization disabled. And with it being disabled, what that means is the cable modem now is going to transmit its carrier to the CMTS. And if any impairments are within that path, the CMTS is now going to receive an impaired upstream channel and then has to deal with that upstream channel. It would have to equalize it and take care of itself. So in this drawing here, I have a CX380C set up in cable modem mode. It's transmitting one of the channels up at 55 megahertz. I split it off right out of the output of the modem to show this is what the haystack of that channel looks like when it's being directly transmitted. I also have it then going through a notch filter, which will then kind of skew the top corner, top right edge of the channel so that when it gets to the CMTS, it's going to look like this drawing over here on the right, or this illustration on the right, which shows the channel is now slightly skewed based on the filter. And this is what the CMTS is receiving. This is what the CMTS has to equalize in order for it to continue demodulating and working that channel. So this is the setup with the pre-equalization disabled. My next example, same setup, but now the CMTS has got pre-equalization enabled. So what happens now is when the cable modem is now transmitting that same upstream channel at 55 megahertz, it's going through the notch filter, and then it's received at the CMTS with that slant that we saw in the first example. But now the CMTS says, hey, I don't want to deal with this every time it comes to me. It sends back information to the cable modem via station maintenance and says, I want you to pre-equalize your transmitted carrier to compensate for this filter or this impairment. So now the cable modem is transmitting. I got a capture of that transmission. You can now see it's an inverted haystack. It's the opposite of what we were seeing of what the CMTS was receiving. So with this inverted carrier, it goes through the notch filter. It goes through that skew of the high end, which basically flattens it out. and then now the CMTS receives a flat carrier, and it doesn't have to do any processing. It just can equalize. It doesn't even need to equalize it. It just goes right into demodulating and continuing on with very little utilization on that CMTS. So that's basically the difference between enabled pre-equalization and disabled pre-equalization, or coefficients. With this becomes a great tool for the technician to use to troubleshoot any impairments that he sees in the upstream or with the cable modem. So what we did was we added this feature to the OFDMA channel so that you can now see the frequency response across the bandwidth of that channel. So we now display with the 380C on the links page, when you click on any of the UCDs across the top, the UCD ID, if it's an OFDMA, not only do we already provide you the frequency of the OFDMA, the level, and the bandwidth of that OFDMA, now when you click on that, if pre-equalization is turned on, we will display the trace or the frequency response across the bandwidth of that channel. With our display, we will show you the start frequency of the OFDMA to the stop frequency of the OFDMA. Once you get the trace and you do any adjustments to that, to the amplifier or the system, and you want to see what the difference is, station maintenance will slowly update it over time, but you can also click the refresh button over here on the right, and this will send a message to the CMTS saying, hey, update the coefficients to the frequency response. So when you click the refresh button, the button will disappear, the trace will stay, but as soon as the button reappears, that will then paint your new trace, and then you're off and you can see any adjustments that you've made. So this is the addition we've added for OFDMA, the frequency response. One of the other things we added is the ability to look at different locations of the frequency response. So we've added a CMTS and cable modem frequency response location view. With this, when you click on the CMTS, or actually the CMTS is going to be the default view. It's going to show you what the CMTS is receiving as its impaired channel, or what it's actually receiving, impaired or not. And then if you clicked on the cable modem, it would show you what the cable modem's transmitting and what its trace looks like. And if you got any confusion on what these buttons are, we've also added an information icon to the screen just below these location views. And by clicking this, we pop up a message that basically describes what each of the location views is. For like the CMTS, this is the trace of the frequency response received at the CMTS before pre-equalization is applied. And then if you were to click on the cable modem, it's the trace of the frequency response transmitted from the cable modem after pre-equalization is applied. So it gives you the ability to see both sides of the transmission. Great troubleshooting tool. It's another one of those where you're at a customer's home and you're seeing an inverted or a problem with your frequency response of that upstream channel, and you go out to the tap and you see it at the tap. You can then go to the amplifier. You don't see it. You go back to the tried and true method of divide and conquer, and you find where that impairment is that's causing your channel to be skewed or out of whack. So again, this is a new feature we've added to the CX380C. Pass this on, show it to the crew. Everybody should be able to utilize this tool and troubleshoot and fix any problems with the upstream that they're encountering. All right, so with that, I'd like to thank you. And if you have any questions, please contact me or anybody within the VeEX organization, and we'll be happy to help you out with any questions that you have. Thank you.